Hello everyone, in today's video we're going to talk about calculus. We are still talking about calculus actually, and in the previous video we talked about the rules which governs when you're talking about differentiation, or if you want to do questions about differentiations. Those are the things that we did last time. If you haven't watched the video, please don't forget to go and watch the video so that you can get the concept or the skill that you're supposed to use in order for you to differentiate these polynomials. So the first example, they have said differentiate with respect the following with respect to x. So we are giving respect to x actually. So we say open bracket, which is 2x minus 3 close bracket and square. So they have given us something like that, and then they have said differentiate this with respect to x. That's what they have said. So how do we differentiate? We are going to use the same rules that we talked about in the previous video. So those are the rules that we're going to use. And the first thing that we're supposed to do to such a question, for example, if you have asked differentiate, which is 2x minus, which is 3. So if you are minus 3, which is squared. So if you're differentiating something like this, first of all, you have to understand that this square simply means this 2x minus 3, they are appearing twice. That's one thing that you're supposed to understand. For example, if you've been given an example of, for example, 2 squared. 2 squared simply means 2 multiplied by 2. So the same rule is the one which is applied here. So first thing, they're supposed to expand it. Before you differentiate, you are supposed to first of all expand it. That's what you're supposed to do. So we are going to say open bracket, which is 2x. So 2x minus 3 close bracket, and another one which is open bracket 2x, which is minus 3. So these are we have expanded it. So after expansion, we're going to multiply, which is the variable which is there, we multiply with that variable. We're going to distribute. So how we're going to distribute, we're going to say 2x multiplied by 2x, it will give us 4x squared. So 2x multiplied by 2x is 4x squared, and then 2x multiplied by negative 3, it will give us negative 6x, that's what it will give us. And then negative 3 multiplied by 2x, again it will give us negative 6x, and then negative 3 multiplied by negative 3, it will give us positive 9. So that's how it will give us. So from there, these are like terms, they are already like terms, so we're going to subtract. We subtract these coefficients. So we're going to bring down, which is 4x. So 4x square, and then negative 6 minus 6, it is negative 12. So it will give us negative 12x, and then plus it will give us 9. That's it. Oh, there is 9 there. So 4x square minus 12x plus 9, that is the value that it has given us after expansion. We haven't yet, first of all, we haven't differentiated it, or we haven't found the derivative yet, but we have just expanded it and we have multiplied it. So after we come up with this one, that's when we can find the dy over dx of each term of this, each term here. So we'll say the dy over dx, because we are differentiating. So the dy over dx of we're going to be finding each term. So we are going to say 4x square close, again minus, there is a minus there, so dy over dx of which is 12x. So 12x for close, again we say plus, which is the dy over dx, over which is a constant 9. So we have got a constant 9 there. So what we're going to start with, we're going to differentiate each term, because these are the sum of the terms. So we have got different types of terms here. So we've got this first term, and then we have got second term, and then we have got third term. So we're going to differentiate each term. So the dy over dx of a coefficient and x squared, these two. So this power you are supposed to multiply with the coefficient, which gives us 8. So 8, and then x. And then from this power you subtract 1. So when you subtract 1 from this power, you're going to remain with the 1. So it is same as we are not going to show the 1 this side. We're not going to show as 1 power, but we're going to say minus. We come to the other derivative. So I've said 2 multiplied by 4, it gives us 8x. And then from 2 we take away 1. Those are the rules which was there. And then from there we differentiate dy over dx of 12x. It is same as applies to 12. So 2 same as 12, and then plus the dy over dx of a constant x is 1. So what I've done here is that the dy over dx of a constant 1 of a constant x, because this 12 has to go in front of the dy over dx, and then you find the dy over dx of the single x. So the dy over dx of this single x is 1. 1 multiplied by 12, it gives us 12. That does not have just the 12 there. And then we come this side, the dy over dx of 9. The dy over dx of a constant number is 0. So 0. And then we add, these are right terms, so it will give us, the final answer will give us 8 x minus 12. That is the final answer which it will give us. So that's the final answer there. For example, we'll say we have got 4 x squared minus or plus, let's say plus 2. So 4x squared plus 2. So this is the other example. So for this one, there's no expansion. There's no need for it to expand. So you just have to find the dy over dx of each term there. So the same way we did, because we're finding the we are differentiating. So each term, which is 4x, which is square, and then we close, and then plus the dy over dx, dy over dx of a single 2. So the dy over dx of 4x squared is the same as 4 multiplied by 2, which gives us 8 again. It's the same, 8x, and then 2 squared, 2 take away 1, it will give us 1. So there's no need for us to show 1 there. And then plus the dy over dx of a single number or a constant number is 0. So it's the same as the final answer will give us the same as 8x. That's the final answer. Example number 3. 2x cubed to the power 3, minus 5x to the power 2, and then plus 2. So this one I'll just do it with the fact that we know that we're differentiating. So I'll just do it direct. So I'll just say the dy over dx of this term here, it's the same as 3 multiplied by 2, which gives us a 6. So 6x. And then from this power, we subtract 1. So 3 take away 1, it gives us a 2. So it's the same as 2 there. Minus the dy over dx of this one. So it's the same as 2 multiplied by 5, which gives us a 10x. And then from this power, we subtract 1, it gives us 1, which is there. And then the dy over dx of a constant number is 0, so it is same as plus 0 there. So this is the final answer. So the way it is that calculus is not very difficult when you know the rules which are applied to each question. So you know the rules which are applied to each question, then calculus is very simple.